All right, I think we can get started. So, hi everyone. When preparing for this conference, I asked Benjamin, like, has anyone ever given a West talk? And apparently not, like not specifically dedicated to West. There's been mentions about West in many talks, and in some cases, I think within Nordic, we've had some presentations about it, and I had an old set of slides from some years back, but there wasn't really a formal presentation in an event like this about West, or at least I couldn't find it. So with Benjamin, I suggested why not give one, because it's something that many people developing with Zephyr use almost daily, and there are things, I think, perhaps especially related to why West is, how it works, that haven't really been explained before and could be of interest to many. So decided to make this talk. Let's then start just briefly about Nordic, since I'm paid by them, might as well mention them. We're a Norwegian fabless semiconductor company who make chips, but we don't make generic MCUs. We specialize in wireless, everything that's wireless and low power. So we don't do gigabit per second type wireless connections. We specialize in low power, low throughput, usually wireless. This includes also cellular. We started a few years back, so we also do cellular now, LTE-M and narrowband IoT, but again, focusing on small applications with small amounts of data and very, very low power that can, you can run your device with a small battery for months. Now we do also Wi-Fi, and this is a new market for us, but it's interesting, and we are getting there slowly. So let's talk a little bit about how we've been involved with Zephyr. We've been there almost since the beginning. We joined the project a few months later, a few months after it was announced, let's say, I don't know, 4 or 5 months. So very early on. We're a platinum member now. We've been since the beginning, and we've been supporters for the project for a very good reason. I'll get to that in a minute. We're very active, I would say. This graph, also by Benjamin, thank you for that. It shows the contribution. I'm not sure how they're calculated. It's not pull requests. It's not comments. It's sort of an average of things. There's some secret sauce there, and Benjamin probably will have the details. But basically, you can see here that the purple top line, that's us, and that's about a quarter of the contribution. So we're very, very active in the project, and we've been since the beginning, and we continue to be. Of course, that includes West as well. We developed West not alone, together with others, and we did so because we needed it, and I'll explain to that why. We needed it as a company, and the project needed it both, so it was a good coincidence. We also have an SDK based on Zephyr. That's actually the fundamental reason why we contribute so much, right? Zephyr is fundamental for us because we ship our software based on Zephyr. So we have a fork of Zephyr, we maintain it, we ship everything together. We put a bunch of stuff around Zephyr that's proprietary and secret sauce and stuff that we don't want to go upstream, and then we ship that. So Zephyr is key for our strategy, our software strategy. We contribute a lot to committees and working groups. You probably have seen me in some working groups sometimes. And we also have a very popular training course online. It's called the Nordic Developer Academy, and it's very popular for those starting up with Zephyr. Either with Zephyr or our SDK, it doesn't matter because the fundamentals are very similar. And I recommend that if you are starting or know someone who is starting with Zephyr. So let's start with West now. What's West? Okay, the basics. It's a Swiss Army command line tool, so it's a command line tool, and it does 2 things. It does repo management. We'll talk about that extensively. And then it also serves as an interface, a command line interface to a bunch of functions, many of which have to do with interacting with the hardware. Some others are more about scripting, maintenance, a bunch of other things, help, debug. So it's both, and we wanted it to be both. And I'll get to why in a minute. It's a fundamental concept for us that it does both. It's written in Python. At the time, there was a big debate back when we started West, whether it should be compatible with Python 2 or not, whether we should use Rust, whether not, but Rust was not as mature as it is now. Python was already part of the Zephyr build ecosystem. We're using Python already to generate interrupt vector tables, to parse the L file, to do a bunch of things, generate IDT tables in some CPUs. So it was already there, it was already required, so adding another dependency didn't really make sense. And this is a screenshot of the current set of commands if you run West in Zephyr. It's a little bit overwhelming, but the reason behind that is the first part is actually the built-in commands, the ones that are implemented by West itself in the tool. And then there's a bunch of other commands that are provided by Zephyr, and they're completely maintained separately and have little to do with the development of the tool itself, and a lot to do with the Zephyr build system and with the Zephyr metadata in device tree, in the CMake configuration files to be able to interact with the device. So now this is something I wanted to touch upon, because many people have asked why we developed, or at least to me, they've asked many times why we developed West, why we didn't take something else, why we didn't adapt something, why we started from scratch. So first of all, we had two problems. You look at these two GitHub issues, they're from 2018, looks like prehistory now, but back then we had two huge problems, and we captured them in these two issues. One, we didn't have a command line meta tool. Everybody else seemed to have one. Back then, there was Minute, they had this new tool, there was Embed, they had Embed CLI, and a bunch of others. And Rust had Cargo, and everybody seemed to have their own tool except us. So we were feeling left out. And also, we had a problem. Our tree had a folder called ext that many of you probably have never, ever seen. But that folder had the equivalent of a lot of the code we have now in external repos. That was growing. And it was giving Anna's headaches every single day. We had conversations about it every week. It was getting out of hand. So we didn't want to have other licenses in the main tree. The size was becoming unmanageable. We had to do something about it. It was just not scalable at all. So we went the single tool, West, after a lot of back and forth. It wasn't a simple decision, but we ended up settling on that. We had a set of requirements. I will get into those a little bit later, but essentially we tried very hard not to write our tool, a new tool, especially for the repo management part. We thought initially we'd make a tool and we'll wrap the functionality, Git repo management functionality that already exists on the tool, so you can use that and then also use it for other things. The problem with that is our requirements were laid out for a reason, and there was Google's repo, and there were Git submodules that sort of fit the bill, but they didn't. Google's repo was a disaster in terms of support. They only supported Python 2. It didn't work on Windows because it required symlinks. No idea what the state of it now. You had to use Gerrit or it was built in, or it was hard-coded to use Gerrit, which at the time we had already switched to GitHub, et cetera, et cetera. And Git submodules had the biggest problem is that with Git submodules, you have to modify the main repository where you define the submodules in order to override, change the revision. You can't just say, leave it untouched, but change the dependencies. You can't do that. So one of the arguments that I brandished back then is you have a single tool also. That strengthens muscle memory. You type that all the time and then consolidate your mental model. I'm using Zephyr, I'm using West. So that was also a big argument back then when deciding this. So next, constraints. We were very serious about constraints and requirements. I remember I felt like I was in a big company instead of an open source project, because we wrote all of these pages of requirements and constraints because we didn't want things to get out of hand. We didn't want to write a tool that suddenly would do all sorts of things, that everybody would add stuff to it and it would become a mess. We had seen that before in other projects. So we set out some serious constraints. First of all, optional, and put that in italics because, yes, it's optional, but sort of. But very, very important, compatible with CMake. You can't, we never, we told ourselves we will never, ever put build logic in West. So everything needs to be reproducible from the command line using raw CMake, Ninja, Make, whatever. So West can help you, but it will never be required to build an application. Because if you start to go in that way, the problem then you have cross-dependencies, West becomes part of the build system. It wasn't a good idea. So that was one big design constraint. But, however, we said it's optional, but it's not necessarily convenient to not use West. So if you don't use West, you have to know what you're doing. You can, but you're on your own, sort of. I mean, we do provide a little bit of help, but you're on your own. Cross-platform, unnegotiable. I mean, that's since Nordic joined and we ported Zephyr from Make to CMake, one of the biggest goals was to be able to run and build Zephyr everywhere, including Windows. So that's usable as a Python library. That's actually proven to be one of the best decisions ever, because we now are able to invoke the West functionality from other scripts, and that's widely used in many, many places. So that's also a conservative feature. That's what I was talking about, not put everything on the kitchen sink there. We started hearing talks about why don't you put there handling of handling of scripting and blah, blah, blah. So no, you write the script and then invoke West from it. We don't want West to become yet another sort of starting point for scripting or things like that, and clearly specified. So now we need a name. And that was maybe the hardest part, as software developers say. So we had a list. I put together a list based on the, back then in 2018, based on the feedback we got from many people. Now, there were some really funny ones. Washoe, it's sort of a westerly wind from Nevada. I said, Washoe, I mean, you can thank me that you're not typing Washoe every day. Vayu, breeze, wind. I mean, some were kind of acceptable, but in the end, we chose West, because it's easy to type, first of all. Ergonomic, you don't have to go like all the, I mean, at least on a QWERTY keyboard. Of course, that we didn't think about other keyboards. That's a good point. If someone has problems with West because they're using a different keyboard, that we didn't think about you. So it's not too hard to pronounce. It was available in PyPy. That was key, actually, because we didn't want to have Zephyr-West or anything like that with namespace. We wanted just the name so that you would do pip install West and be done with it. So also it evokes, obviously, the Western wind of Zephyr, and it wasn't offensive. Some of the proposals turned out to be some parts of the anatomy in Arabic, and some of the proposals that were there, so it was a no-go. We had to be careful about that as well. So we approved the name in 2018, in May, and that became the name of the tool. That's actually one of my proudest contributions to this project, just because I think it's a good name, and I'm happy that it was chosen. All right, so continuing with West, it's developed in its own repo. It's not developed in the Zephyr repo, except for the extension commands. We'll talk about those. Those are in the main Zephyr tree. Then published on PyPy, we've already mentioned that. And it was originally developed it was a collaboration between Nordic and open source Foundries, which then later became Foundries.io, and then I think they got bought anyway. But it was a collaboration between these two companies, so we did it together because we needed it, and they actually had sort of a cobbled together homegrown solution that sort of did a little bit of what West did, and so there were some ideas there. We didn't take any code from that, but we took ideas. Now it's currently managed by Peter, who's here in the first row on GitHub. Thank you for being a great maintainer. And let's start with repo management. So the first set of commands. Essentially, they used the repo management commands. They used to initialize, update, and manage these things called workspaces and manifests. We'll get to that. Again, going back to why we didn't use Git submodules. First of all, and most important reason, no need to modify the main repo to overwrite or modify or extend or remove or change in general any of the projects. Whoops, went black. Okay, we're back. So, and you don't have to modify the main repo. That's key. And then the other thing is continuous tracking. At least until back then and probably until now, some modules don't allow you to track a branch. You have to specify a particular SHA every time you set a revision. So essentially, repo management is about just managing a bunch of Git repos together at a particular set of revisions. We support multiple topologies. You can, as I said, you can freeze to a SHA or track a branch. Track a branch means every time you run West update, it will update, basically, to the latest at the time when West update is executed. Only compatible with Git at this point. Terminology, workspace. Okay, a workspace is the enclosing folder or directory that contains a West directory in it, which a little bit of metadata, and all the manifest repo and all project repositories. It's almost always created by the init command. Top there, it's the root of the workspace directory. Manifest, that's a key concept here. It's a YAML file. We chose YAML because it was, again, an obvious choice in terms of which language to use. It's usually named west.yaml. It doesn't have to be. You can configure that. And essentially it determines the URL path and revision of every single project. And we'll get to projects now in a minute. The manifest repo is the repository that contains the manifest file. It doesn't even technically need to be a repo. It could be even a folder, because West does not ever touch that repo, ever. That's something that some people find confusing in the beginning, and I understand that, but West never ever touches the repository or the folder where the manifest is, except of course West init, which creates it. Manifest ref is an important concept, but one that you can live without. It's just there for reference. It's a branch in each of the project repos that points to the current revision as specified in the manifest. Finally, a project, an entry in the manifest, an entry in the list of projects. Basically, it represents a repository that is managed by West. And finally, a module, we'll get to the difference between projects and modules, which is a directory, not necessarily a repo, not necessarily a project, that has this particular file in it. All right, so the next slide is about a visual representation of all this. So you have a directory, which is your workspace. In this case, it's the Zephyr project. So you can see that in my case, I've named Zephyr project the workspace. So I run West in it, and then I've used Zephyr project as the name. And then we have a West directory, which is a metadata directory that typically only contains a config file. That's it. So it temporarily contains other things, but mostly it's just there for the config file. It's there also to signal to West that this is a workspace. Then you have the manifest repo, in this case Zephyr, the manifest itself, in this case west.yaml, and finally a bunch of folders that can be anywhere. Like here, I've shown them in a linear sort of non-hierarchical way, but if you look at the right-hand side, you can see that you can place them arbitrarily wherever you want in the file system within the workspace. So essentially, that's the contents of a West workspace. That's all there is to it. Let's take a look at the manifest file. This is a modified Zephyr manifest. I took the Zephyr manifest and then modified it slightly just to be representative of what a typical manifest looks like. So defaults, very simple. It's just a set of shortcuts. So if you specify defaults, every time you don't specify something, in this case remote, it defaults to whatever you write. So in this case, if you don't say remote, it's upstream. Remotes, that's just like Git remote, essentially. They have a name and a URL, and or URL base. So essentially, you will add the name of the project at the end of the URL. So they are just pointers to repos. They don't have to be on GitHub, obviously. It can be anywhere as long as it's a Git repo. Projects, it's a list, and each entry in the project has a name, which uniquely identifies the project. It has a revision. We'll talk about this a little bit more. And then there's a path where it lives inside the workspace. This is always relative to the top there in the workspace that we talked about, so to the top level folder. There's another one called HAL Nordic, and then finally there's a third one, and this one you will notice that has the remote at the bottom pointing to the Nordic one. So in this case, instead of being fetched from the default remote, which is upstream, it's overridden, it's fetched from the Nordic one. And finally, there's a self section. It actually talks about the manifest repo itself. So in this case, what we're saying is, I want you, when you initialize the workspace, to put the manifest repo in a folder called Zephyr. That's important. So self refers about the manifest repo itself. Import, very, very key keyword in West, and one that hopefully you will use because it's very powerful, and I think it's good practice in general. So we have a Zephyr sample called example application that's outside the main tree and that demonstrates the import feature and many other features and many out-of-tree functionality in Zephyr. So essentially how this works is we have a project here named Zephyr. This is not the Zephyr manifest. This would be akin to your application manifest, something that you use in order to have your application in Git and as well to pull Zephyr to use it in your app. So the import keyword, what it does, essentially what it says, right? It pulls in all of the projects, in this case, all of the projects from Zephyr, which are in the Zephyr manifest, into yours. So suddenly, your manifest is, obviously, your manifest repo, Zephyr, and all of its projects. Then if you add a new project in your list with the same name, so Zephyr contains a HAL Nordic repo. It already has one. Now, what's done here is I've created a new HAL Nordic pointing to main and with a remote myself. So this means that what happens here is that when you run West update, the HAL Nordic that's in the Zephyr manifest will be ignored because any projects that are defined outside of an import statement, so in the main manifest, take precedence. So that means that the HAL Nordic will be used is mine. And this is a great example of how can I for example, start tinkering with a module or a Zephyr project that's a dependency to Zephyr, you can just create your own manifest, override both the fork, the URL, and the revision, and start hacking with it. And once you're ready, you can then submit the pull request or whatever. Or, for example, if you've detected a bug, you don't want to submit it to the upstream project for whatever reason, you can fix it yourself in your fork and override it. So this is a replacement of the HAL Nordic and Zephyr with my own. Another key thing is that when a project with the same name appears in multiple imports, the first one is taken. So if you happen to import from 3 manifests, the first hit on a particular name is the one that's taken. The import keyword is more powerful than just true. There's true, but there's also you can do it by relative path, meaning they import a particular YAML file from remember that manifest file, that west.yaml, is relative to the A project folder, obviously, not to the top dir folder, because it's telling you where the manifest for A project is located. Then mapping, this is very powerful, very much used by many. Name allow list is also, I think, extremely useful. It's also used in the example application. It allows you to filter by name. So imagine that you're writing an application, it's only for Nordic chips, and you're doing some crypto, but that's about it. You only need HAL Nordic and embed TLS out of the dozens of projects that Zephyr has. Then you write name allow list, you select the projects you want, and everything else will be filtered out. Nothing from Zephyr will make it into your workspace, only the ones you want. There's also a path prefix, which can be useful. It's basically you're telling it, place all of the modules from Zephyr into this folder, if you want to keep things tidy locally. There's also another option. I won't go into details. It's usually useful for CI, etc. You can have a sequence of files where you import multiples of manifests. I've seen these used in the wild. For example, I think NXP in the next-gen repo. If I looked a little bit yesterday evening, and I think they're using this. So anyway, it's another way of importing, in this case, by path, by sequence of paths. Init. West init. So that's typically the first thing you start with when you work with Zephyr and West. It creates the workspace directory. It creates the West config directory we already talked about. Obviously, that's key. And then the first thing that it does, it clones the manifest repo, right? West init typically takes a parameter, but by default, it will clone Zephyr. It's hard-coded in it. So it will clone the manifest repo, and it will put it temporarily inside the .west folder, and then it will move it. It needs to do that because it needs to find out that self-path app section that on the bottom right. Once it's found that, it can move the manifest repo to its final location. So in this case, app from the top there. So this is what it does unless you specify local. If you invoke it with L, essentially what it does is it skips the cloning part. It skips the moving part, and it just leaves it there in place and creates an enclosing folder around it. So it essentially leaves that's why it doesn't need to be a Git repo. Git never performs Git operations on the manifest repo except for cloning, and that's it, for cloning it initially. So update. West update does the following in terms of logic. First, it clones the project if it's not there. So it looks at your workspace. It looks at your manifest and checks for every single project if it's there already or not. If it's not, it clones it. Once cloned, it fetches if required, because Zephyr is smart by default. So it will say, okay, your revision is SHA ABC, and SHA ABC is already locally. I don't need to go over the network, so it won't. It will say, okay, it will just change the revision to that. But if the revision is a branch, it always needs to fetch, because you don't know what the state. You know when you last push to a branch. A branch is a moving target. It doesn't identify the point in time. So it always fetches in that case. If not, it skips the fetching. Then sets that manifest ref branch to the corresponding revision in the manifest file. So essentially what happens there is, okay, I have a branch in my project folder. I'm going to point that branch to the corresponding revision that you're asking me. If it's a branch, it will point it to the latest SHA, the head of that branch. And finally, checks out a detached head at that revision. Why a detached head? It was a really heated debate that I really don't want to repeat, but it's essentially, to sum it up, People hate detached sets, I know, and they're ugly, and you get the warning from Git and blah, blah, blah. But the thing is, the alternative was fighting against branch names, because otherwise we would have had to kind of make up a branch name, a default branch name when you check out. People would have liked that, and they would risk of collisions. And back then, Martí Bolívar was working on this, and he and I decided that's not going to work. So we just used detached head. That's actually something from Google repo that we wanted to avoid, but we ended up saying folding. We folded. And one very interesting set of options for West Update is that you can do keep descendants and rebase. This is essentially very interesting when you're developing on your module or your project. Imagine you have your own project with embed TLS, and you're making changes there. You have a branch. When you do West Update, you don't want West to touch that because it's your branch. So you can either keep descendants, which means West won't touch the revision of that project. It won't modify it at all, as long as your branch is a descendant of the revision specified. So basically, you are adding to it. Or you can even specify rebase, where essentially West will rebase your changes on top of the latest manifest rev. So that's very useful when you're developing projects, and you want to also update the revision of other projects with West Update, but at the same time, you don't want West to override your work. So groups, those are useful. They're used by Zephyr quite a bit. They're used in our SDK as well. Essentially, it's a way of filtering out projects. So we'll see now how that works. Projects are disabled only if all of the groups that a particular project belongs to are disabled. So it's an OR. And what happens here is, in this particular case, we have a group filter statement at the top in yellow that says disable the optional group. So in this particular case, right, what happens is the crypto group is enabled by default, the optional group is disabled. So the ZCBOR project is disabled, whereas the embed TLS project remains enabled. You can override that. That's by default when you use the manifest, but you can actually locally override that, and it takes precedence also over the configuration, over the group filter setting in the manifest. And you can do that locally. Imagine I'm not interested in the optional repos in Zephyr, for example, or whatever other category. I can do West config, manifest group filter, and then plus or minus whatever I want. And you can even add and append to that string if you want. And that's, or you can edit directly the config files always. Huh? I will take you to that in a minute. So, and that allows me to locally decide whether I want those repos or not. Topologies, very quickly. The first one is Zephyr. How Zephyr works, it has a manifest, and then, a set of projects, some of which are forks of other open source projects. So, for example, in this case, we have OpenThread and LVGL. Those are open source projects that have their own upstream, their own organization on GitHub. And what we do is we fork those into the Zephyr project RTOS GitHub org, and then the manifest points to those. This is for safety, so that if the upstream project goes away, we don't end up with a manifest that doesn't work anymore, right? So there's the T2 topology. This is a graphical representation of what I said before. This is essentially importing Zephyr. So this would be your application. This import statement brings the projects that Zephyr has into your workspace, so you don't have to do anything, and they're automatically pulled in. But I'm overriding HAL Nordic, just like before. So in this case, so I forked the Zephyr HAL Nordic into my own GitHub account, which is something you do frequently. And then I'm pointing to that one instead of pointing to Zephyr. So if I want to play around and have or just, like I said before, maintain a series of patches that I don't want to go upstream, I can have that, and that works really well. So this is one of the main reasons why we're talking about that some modules would have never worked. I don't have to modify the Zephyr Git repo at all here. In my manifest, I'm saying take Zephyr, but override this one. This would not ever work with Git submodules, or at least back then. I don't know if they've changed since we have West. I haven't looked at them again. Few other commands. You can have West list. It's very powerful. It allows you to list all projects, and you can specify the format. Manifest allows you to freeze, resolve, or validate the manifest, so validate that you can do the import, etc. You can even use onTrack now to show, it's a bit like Git status shows you onTrack files. You can do that with West manifest onTrack to see stuff that you have on your workspace that doesn't belong to the manifest. So, for example, a project that has been renamed, or you just created some files, local files, that are there, and it will show you that. Compare is actually very powerful. If you want to check if everything, all your projects are at manifest ref or something has been checked out, this will tell you. It also tells you if you have uncommitted changes in the projects, and also if you checked out the branch instead of the detached set. Diff and status is just a shortcut to run those Git commands on one or more projects. For all, it's the same, but by running a script. And finally, grep runs a tool in a bunch of projects. Brief sort of sidetrack with projects versus modules. This is, again, a confusing topic often. So West projects are not the same as Zephyr modules, but a project can be a module, and a module can be a project. So essentially, what they are is, well, West project, we've already been looking at them for some time now. Though they are each of the entries in the project's a key in the manifest, so you have a bunch of those. Whereas Zephyr modules are directories, usually a Git repo, but they don't have to be, that contain a Zephyr/module.yaml inside it. Now, the thing is, this file means that if Zephyr finds it, either via West or via another means, it will integrate it, it will pull it into its build system. So it will read its config files, device tree, boards, etc., and integrate all of that, and it would be as if all of that were in the main Zephyr tree. So it's a very powerful way of expanding Zephyr without touching the tree again. You can use the Zephyr build system can either use Westlist to locate those modules, but also you can provide them directly. Again, a reminder that you can use Zephyr without West, even if you want to use Zephyr modules. So that was also an important thing. Extension commands, they are very useful. Again, there's a way, you want to extend West, you want West. I think I saw you had an extension command yesterday for you were using West for cpatch, I believe. Yeah, so I thought, okay, I'll mention that tomorrow. So this is very useful because you can, instead of having your own script and telling people how to invoke it, you can just extend the set of commands in West, and that's what Zephyr does. And how it works is just a simple pointer to the West commands file in the manifest, in this case in self, but you can have it anywhere. You can have it also in a project. And each of the commands is specified with a file, name, class to instantiate. It's a Python class, and little more. It's pretty straightforward. There's a template on how the command you have to inherit from a class, but it's very easy to write and very powerful. Yeah, you can have commands from multiple projects, and West will show them separately. We'll say this bunch of commands come from this project, these from this, and this from that, and it's very clear what comes from where. They're also imported. So if I import Zephyr, I also get all of the extension commands. If I didn't, then in my example application, I wouldn't be able to run West build or West flash. Continuing with extension commands, here's the set of extension commands that Zephyr provides. We'll just go quickly over those. You're probably very familiar with those. So list boards, build, flash, debug, attach, RTT for Seger output. Metadata completion for shell completion. I haven't used that with West. I highly recommend it. It's very powerful and works pretty well. I think we support most shells now. SPDX to generate an SBOM. Binary handling, so blobs to pull binary blobs from the different repositories that the vendors provide. Binary descriptors to create or manage binary description entries in the binary. Testing, sorts of testing. I'm sure there will be talks about Twister, and then installation. Those are ancillary things. But if you haven't used them, actually, because they are relatively new, especially SDK and packages, they're powerful and very useful. I very much recommend you to look into those. SDK will automate the installation of the Zephyr SDK, so the toolchain, and packages will allow you to install the Python packages automatically and manage that for you. And then finally, some utility commands like patch to tell West to patch, actually apply a patch. Many people were asking for that. Apply a patch after updating, and gtags to manage your C tags. Configuration. West is configured almost identically like Git. So you have typically a system file, a global file, and a local file. The local file is in the workspace directory /.west config. And configuration is achieved either by, just like Git, editing the files directly or running the West config command. Now, a few interesting ones that I think some of you may not know and that are very useful. First, manifest.path. This one is key. Someone was thinking, Ryan was mentioning it yesterday, and it's very useful. It's very useful, especially if you're handling multiple projects, each of which has its own manifest. Because then you can have two workspaces, or you can do everything in a single workspace and use manifest manifest.path to tell West which manifest to use whenever you run West update. The advantage there is that you, as long as the paths are the same, for example, for Zephyr and other modules, you don't need to have two clones. You can have a single clone of the repos and switch between revisions with this. How does that work? So let's say I do west config manifest.path app, following the example from before, where app was my folder and contained my manifest and west update. Now I'm using my manifest. But let's say I want to work on some upstream Zephyr feature. So what I do is I tell West to switch to the Zephyr manifest, update, and suddenly I'm in upstream Zephyr. So that's very useful, especially if you want to save space or just like to work in a single workspace. The alternative, obviously, is to have two workspaces. More configurations, a few more. Build has a bunch of them that are powerful. Build pristine, it will automatically clear your folder, remove your folder if it detects it needs to. The default board, use that all the time. Then you don't have to specify a word when you build. By default, you can obviously specify it, but you don't have to. Adding CMake arcs to each of the builds, that's also very powerful, where you, in this case, I want to export the compile commands every time I build, so I just add that and it will be added automatically. Sysbuild, for those of you who have learned about Sysbuild and its features, you can enable it by default. It's disabled by default with West, but you can enable it by default with this configuration feature. Aliases, similar to Git, again. In this case, aliases from Peter, thanks for those. This one will run for example, QEMU by running build without deleting the folder and the target, the CMake target being run. And this will execute the QEMU simulation, for example. Menu config, same thing, but instead running menu config. So useful to see when you can, useful to have, then you can do West run, West menu config, and that works. You can list all the config options with West config L. You can delete an option with D, and you can even append to an option. This is useful for the group filter, for example, where you can have a sequence of filters of enabling and disabling projects separated by commas. A couple of things about West and GitHub. You can have private repos. I recommend the following way of handling them. There's many ways of handling them, but perhaps the simplest, depending on your setup, if you're using SSH, and if you store your SSH key on your GitHub profile, the simplest way is to tell Git to redirect everything that's HTTPS GitHub to SSH GitHub. Then you essentially magically connect always via SSH, and West will never complain. Obviously, West doesn't control this, but this is just a tip. Pull requests for the revision, while the pull request is not merged, you can use pull / the PR number and head in the revision field to point to it. And finally, we have the manifest GitHub action. It's very powerful. If you're using pull requests and GitHub with West, highly recommend to use it. It's open source, and it will display, for every time you change the manifest, it will display what the changes are, and it will create some links to the diff, etc. So it's very powerful. And finally, last slide about the future. West is now mature and stable, but that doesn't mean it's stopped developing. So West is actually used outside of Zephyr. I was mentioning earlier the NXP next-gen SDK, and they're using it without Zephyr now, and it works well. But the problem is it still looks for Zephyr base, and it fails. That's an environment variable that many of you probably have never used if you weren't using Zephyr a long time ago, because with West it's less useful, but it's still tied to that. The handling of Zephyr.base, which is a config option, it's a bit wonky. And yeah, there's an issue if you want to help out with that purpose, there's an issue tracking this. There's a really nice pull request with automatic cache handling where you can essentially tell the West that, hey, start caching there, and then in a particular folder, and then wherever you update any project on any manifest, it will check if it's there, if it's in the cache, and then it won't clone it from scratch. So very powerful. It's not merged yet. And finally, what we need to do is a documentation website, because right now we're piggybacking on Zephyr, but really West is big enough and a project that it belongs in its own website. We need to do that at some point. And that's it. Thank you very much. Thank you. I'm not sure if we have any time for questions. Any questions? Yeah? Go ahead, Chris. Yeah. No. With West, you don't, because essentially ZephyrEnv.sh was a way of setting Zephyr base, the environmental variable, and now West does that by default, because what it does is, if you're inside the workspace, it will auto-detect as a folder called Zephyr by default, and by default also if you clone a manifest, or if you init a manifest that has a Zephyr project, a project called Zephyr, it will write the location of that project inside the config file, so you don't need that anymore. If you build with West. Exactly. If you're not using West, then you may need it for sure. Yes. Yes, correct. The Zephyr base, you mean, or? Oh, ZephyrEnv. Really, to check patch? Oh, okay. When I run check patch, I don't remember. Possibly, huh? It might be. I don't set it anymore. I know, but because I checked yesterday. Do I have it set? No, I don't. But maybe check patch. I don't know, because I use to run check patch. I don't run it directly. I use I use script CI. And that actually sets Zephyr base. So that's why you need it, and I don't. Yeah, I run compliance directly, and that sets Zephyr base.